Okay, here's a little video on the error bounds when we're approximating integrals in 5.9. So, for example, we might be asked to use T10, meaning the trapezoid rule with 10 trapezoids, to approximate an integral that we can't take nicely, and you know that because the reading says so. So we're going to skip that for now. The book explains that pretty well, but people have issues with the error bounds. So let's look at part B. We're asked to estimate the error from part A. So that means using the trapezoid rule and 10 rectangles, or 10 trapezoids. So we look up the trapezoid rule, so I'm working on B here, and it says that your error, due to the trapezoid rule, is going to be less than or equal to a fraction k times b minus a, that's the domain of our integral, cubed over 12 n squared, where n is the number we take. So for us, n will be a 10. The hard part for everybody is this magic k, and they tell us that k needs to be bigger than or equal to the absolute value of f double prime of x on the interval a to b. And that makes it really easy if you remember from Cal 1. We're told that we achieve an absolute maximum either on an endpoint or at a critical point. So what it's telling us to do is take two derivatives, and then if we're nice teachers, then we're going to give you something where there are no critical values in between. So we're going to assume for the purpose of this class that you plug in both endpoints, A and B, once each. Whichever number is bigger, that's the maximum, and you're just going to let k equal exactly that number. That guarantees that all the other second derivatives were smaller. So let's try it for this one. If we know that f of x is the integrand e to the x squared, and f prime of x, we use the chain rule, so we're going to get 2x e to the x squared, and then we've got to use our product rule. F double prime of x is 2 e to the x squared, plus we're going to get another 2x when we integrate the e term, so we'll have 4x squared e to the x squared. So not too bad. Now we want to take f double prime of 0, which is 2 e to the 0. A lot of people immediately say the answer is 0, but e to the 0 is 1, so that doesn't really go away. Plus 4 times 0 times e to the 0, so that's a 2. That's not very large, but we'll see what happens. F double prime at 1 is 2 e to the 1 plus 4 times 1 squared times e to the 1 squared, which is just 6 e to the 1s. And e to the 1 is just the number e, so you don't have to write the exponent if you don't want to. So 6e is going to be a lot bigger than 2, so that is our k. As soon as you do this second derivative, plug in both endpoints, you take the bigger number and you say k is now that bigger number. And we're done. We just plug into that nice easy bound that we wrote above and say we know now that our error from using the trapezoid rule is going to be less than or equal to 6e's times b minus a is 1 minus 0, because those are our limits of integration, cubed over 12, and we're using 10 trapezoids, 10 squared. So this is equal to 6e over 12 is just e over 2. 2 times 10 squared is 200. And that's about 0.1359. So our answer to part B would be 0.1359. That's our approximate error. Oh, excuse me, 0.03. 0.01. I can't read my own writing. 1359. So that's how you would answer part B. You literally find what your k is and plug it into this fractional bound up here. In order to answer the question like part C, it's just like everything else you've done in math. We're just asking the question in the opposite direction. Instead of giving you the function, the k, the limits, and the n, and then solving for the error, we give you the error and you solve for n. So to do part C, you take the same thing, k, b minus a, cubed over 12 n squared, and you want to make sure that it is less than or equal to 0.0001. It's usually easier to work with fractions since I'm going to have to swap sides, cross multiply and things like that, so 1 over 10,000. Okay? Now, if this was a brand new problem, I would have to solve for k again, but it's not, it's a part C, so I already have k from part B. So I can progress and say that this is now 6e times 1 minus 0 cubed over 12 times n squared is less than or equal to 1 over 10,000. In order to solve for n, we multiply both sides by n and multiply both sides by 10,000. The 6 and the 12 still cancel, so we're going to get an e times 1 for our 1 minus 0 cubed times 10,000 over the 2 that's left from the 12, and that needs to be less than or equal to n squared. So if we take the square root of both sides, we're going to get what n needs to be. N should be greater than or equal to the square root of whatever this is. So 10,000 over 2 is 5,000, so 5,000 e. And if you plug that in your calculator, you'll get that that is n greater than or equal to 116.5. Well, if you're thinking through what this actually means, we're asking how many trapezoids do you use? You can't use part of a trapezoid, and it needs to be bigger than this number, so we've got to round up. So we're going to let n needs to be at least 117. We need at least 117 trapezoids to be more accurate than 1/10,000th. And that's our answer for part C. It's really not hard. Remember, to get k, you take the second derivative and you plug in both endpoints. Unless we're being mean, that's all you have to do. Hope that helped. Have a great day.